The charge air and exhaust system. During operation or just after the engine has been stopped, most of the engine will be hot. Touching the engine parts may cause burns. In this system, be especially aware of the following parts. The turbocharger and connecting piping will get extremely hot. The charge air receiver may reach 70 degrees Celsius. The exhaust system will get extremely hot. Even though the exhaust manifold is well insulated, flanges, especially close to the turbocharger, may cause severe burns. Charge air is drawn through the compressor side of the turbocharger and continues to the charge air cooler fitted beneath the turbocharger. After the charge air cooler, the flow goes through the charge air manifold. From the manifold, the air is distributed to each cylinder. After combustion, the exhaust valves open to the exhaust manifold. The manifold leads the exhaust flow back to the turbocharger, where it drives the turbine rotor. Thereafter, it is carried through possible heat exchangers and silencers to the atmosphere. Look for any leakages, tighten and change seals if necessary. When operating on heavy fuel oil, the exhaust temperature will increase somewhat due to the slower combustion of that type of fuel. An increase of approximately 10 to 20 degrees Celsius over diesel oil operation is normal. It is important that the values from these instruments are checked and recorded every day according to the log sheet to assure that the operating staff will notice significant changes. Click the components for further information. The insulation screen must always be in place when the engine is running, because the exhaust manifold is hot and contact may cause fire or burning accidents. The main purpose of the charge air cooler is to reduce the temperature of the charge air. Engines running on heavy fuel oil are always fitted with two-stage coolers. Stage 1 is connected into the engine's jacket water circuit, while Stage 2 is cooled by seawater or low-temperature fresh water. The heat from the jacket water is used to heat the charge air at low engine load. Two-stage air coolers are fitted with drain channels to ensure detection of leakages. If water leakage, water will come out of the telltale hole. Air leakage can be detected by a whistling sound. In case of water or air leakage, the end cover gasket has to be replaced. If a seawater cooling system is used, the end covers should be disassembled at regular intervals for inspection and cleaning. When out of service for longer periods, drain and leave drain and venting cocks open. If using seawater cooling, flush with fresh water. The exhaust gas from the engine drives the turbine, which drives the compressor. The compressor unit sucks in and compresses the air required for the engine. Click the text. The compressor side of the turbocharger should be washed daily. This should be carried out at no less than 75% engine load. Remove the screw on the top of the tank. Fill 0.4 litres water into the water tank. Tighten the screw. Actuate the valve towards the spring and hold it for about 10 seconds until all water has been injected. Engines running on heavy fuel oil should have the turbocharger's turbine washed once a week. Run the engine on marine diesel oil during the water washing. Open the drain cock and ensure that hot exhaust is coming out of the drain pipe. If not, clear the blockage. Adjust charge air pressure to 0.3 bar by reducing engine load. Run for 5 minutes before washing. Connect cold water supply from the ship's fresh water system to the water pressure regulator connection. Open the water injection valves before carefully opening the water to the hose. Check water pressure. If necessary, adjust to 1 plus minus 0.2 bar. Cleaning should go on for 10 minutes. Only water vapour and some drops of water will come out of the drain cock. Shut off water to the hose and close the water injection valves. Disconnect the hose. Run the engine at same load for 5 minutes to dry up the turbine. Then shut the drain cock. Increase engine load to normal for evaporating of condensed water. Click the text. Check oil level once a day. The oil level should be inside the red circle while it stands still. If the colour of the lube oil has turned significantly darker than it was the day before, there is a possibility for seriously damaging the turbocharger. Increased foaming in the oil gauge glass is an indication that the oil should be changed. Remember, both bearings have their own oil reservoir. The turbocharger must not run when oil is being changed. Open the drain plug and the filling plug on the bearing housing cover and drain the used oil. Fasten the drain plug. Fill the lubricating oil up to the upper mark on the sight glass. Place the gasket on the filling plug and fasten it thoroughly. Remember, both bearings have their own oil reservoir. Generally, we recommend a synthetic lubricating oil, which should be changed at least once per 5,000 operational hour. When refilling oil, follow the same procedure as when changing oil, except from opening drain plug. Remember, both bearings have their own oil reservoir. Starting air system. Note: the starting air shut-off valve must be opened to lead air from the bottles to the main starting air valve before the engine is started. To provide sufficient information about the operational parameters and to assure that the operating staff will notice significant changes in the system, it is important that the values from the instruments are checked and recorded every day. Click the components for further information. Start air distributor. The start air distributor supplies starting air to the cylinders in correct order. It is driven by the camshaft. The relief valve protects against overpressure in the system. If the metal membrane in the relief valve is broken, the failure in the starting air system has to be detected before start. It is very important to place the disc correctly. Refill the lubricating chamber with grease twice a month. Starting air compressors should have a sufficient capacity to keep the pressure in the starting air bottle sufficiently high to start the engine. Fill the bottles from atmospheric pressure to maximum pressure in 60 minutes.